Hey everyone, it's Justin, and in this video, we'll be using only half of an ordered pair to find out what the other half has to be. So we know that if I give you an equation and an ordered pair, you can plug in the ordered pair and see if it's a solution or not. But what if I give you an equation and only half of the ordered pair? Let's see what happens. I think you'll appreciate just how easy this is. So when we had the full ordered pair, we could just plug both values in. So let's see what happens if you plug in just the one we do know. So if x is 2, then negative 3 times 2 is negative 6, plus 2 is negative 4. Wait, what does this say? Y equals negative 4? Does that mean the y coordinate in our ordered pair is negative 4? Sure does. Proving it is pretty easy. We've already substituted 2 for x and simplified the right side. So if we just plug in negative 4 for y, we get negative 4 equals negative 4. So sure enough, the second part of our ordered pair has to be negative 4. So now that we've seen what happens when we substitute just one variable, we can see the essential steps to complete a two-variable solution when you already have one of the values. Substitute the variable you already know and simplify. With most equations, the second variable will still be jumbled up with the other values. This is why this third step is important, even if we didn't need it for the first example. Solve for the other variable. The first example was already solved for y, but in the next couple examples, you'll get to see this final step in action. All right, next problem, 3x minus y equals 12. Plug in the variable we know, then simplify. If we plug in 3 for x, 3 times 3 is 9, so 9 minus y equals 12. This one didn't work out automatically like the first one did, but it's pretty obvious what we need to do. Isolate the y, so we get y equals some number. To do that, we're going to subtract 9 to cancel the positive 9. And since that negative means there's a negative 1 on the y, divide it off. So y equals negative 3. Let's check our answer. If x is 3 and y is negative 3, then on the left side, 3 times 3 is 9, minus negative 3 is like saying plus 3, so we get 12. 12 equals 12 tells us that our solution is correct. All right, we got time for one more example, so let's crank the difficulty up a bit. This time, we have multiple instances of each variable mixed up on both sides, and we've been given the y value instead of x. Just remember the steps, substitute the variable you already know, simplify, and then solve for the variable that you didn't substitute. First, we plug in the variable we do know, which is y, and then simplify. Y is negative 2, so on the left, negative 5 times negative 2 is positive 10. And on the right, 3 times negative 2 is negative 6. Next, we just solve for x. Subtract 3x from the left side. Then add 6 to cancel the minus 6. And we see that x is 16. I'll let you check the answer. Remember, plug in 16 for all the x's and negative 2 for all the y's. Then see if both sides come out even. That's it for now. In the next lesson, we'll be using our knowledge of ordered pairs to start graphing equations.